Class, let's go ahead and get homework for 3-3 done. It says in exercise 1-6, determine whether the graph represents a linear or nonlinear function. Well, for number one, this is definitely not a straight line. And when we're talking about linear, we're talking about a line, not a curve. So this is not a function. The graph is not a line. The function is nonlinear. Okay? All right. Next it says, number 3 shows a line going straight down. This is a continuous line. Because it is a continuous line, it is a function that is linear. For number 5, though these are straight lines, they are not continuous straight lines. They stop at when x is 0 and go in the opposite direction. This is not a line. The function is nonlinear. I'll let you do 2, 4, and 6. Number 7 through 10 says, determine whether the table represents a linear or nonlinear function and explain. All right, for it to be a linear function, everything has to increase by the same amount on both sides. So over here, we got an increase of +1. Over here, we got an increase of +1. Over here, we got an increase of +1. Over here, we got an increase of +5. Over here, we got an increase of +5. And over here, we got an increase of +5. So because of this, this tells us that our this function is linear. It is linear. The x increases by 1, the y increases by 5. The rate of change is constant, so the function is linear. The other way to do this is to divide y by x and get the same answer. 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. 20 divided by 4 is 5. All right, let's go ahead and go on through here. Remember, we're talking about, is it linear? It has to go ahead and increase by the same amount. Now you have number 8, number 9 is next. For number 9, we see an increase from here to here of 4. From here to here of 4. And from here to here of 4. Over here, we have to see, is there the same decrease? Well, 16.8, let's see, 16.8, I'm just going to do the work over here. 16.8 minus 12.6. That's going to give us a 2 and a 4. So it's decreasing by 4.2, minus 4.2. So it has to decrease that much every single time. So if I take 12.6, it has to decrease by 4.2 and become 7.4. Well, 6 minus 2 is 4. And 12 minus 4, though, is 8. So this is not going to be, the same amount. And I'm just going to, if you wanted to go ahead and check and see, just taking 4.2 again away from 12.6, we get 8.4. That is not the same. This is an increase actually of 5. Let's see. Yeah, you'd have to decrease it by 5.4. Wait, it's 5. Yeah, 8.4. Yeah, it would be 5.2. Okay, we're subtracting 5.2. And then over here to here, well, not that we have to check anymore because the minute we even had one that was different, that told us all we needed. But if you took 7.4 and you minused, let's see, 4.2, you see again, you're going to get 2. And that would be 3.2. This is not going to give us the same thing. So number 9 is not linear. As x increases by 4, y decreases by different amounts. The rate of change is not constant, so the function is nonlinear. All right, number 10 is for you to do. I'm going to go on to number 11. 11 wasn't on our list to do, so it looks like I have 13. In exercise 13 and 14, describe and correct the error in determining whether the table or the graph represents a linear function. Over here, we see an increase of 2, an increase of 2, and an increase of 2. Over here, we see an increase of 4. Well, no, actually, we see we're multiplying it by 4. And over here, we're multiplying it by 4, and over here, we're multiplying it by 4. It says as x increases by 2, y increases by a constant factor of 4, so the function is linear. Is this true or not? I would say it's not true. It has to be something that's added on every time. So a linear function should have the same amount added to or subtracted from the output values when the input values have the same amount added to or subtracted from them. As x increases by 2, y increases by different amounts. So the rate of change is not constant. This function is not linear. All right, let's go ahead. You have number 14 to do. We're going to do number 15. It says determine whether the equation represents a linear function. Now remember, linear means we can write this as y equals mx plus b. First one says y equals x squared plus 13. The minute you have something squared, it is not going to go ahead and be linear. So number 15 is not linear because this is not in the form of y equals mx. This is in the form of y equals, I guess, mx squared. So you cannot rewrite the equation y equals x squared plus 13 in the form of y equals mx plus b. The equation represents a nonlinear function. All right, 16 is for you to do. Now we have 17. Y equals the square, or excuse me, the cube root of 8. All right, minus x. So we know that we could take the cube root of 8 and turn it into 2. So you can write this equation, y equals the cube root of 8 minus x, as y equals negative 1x plus 2. All right? And you might be saying, how can you do that? We're going to explain it right here. Remember, my x is over here, right? So I can go ahead and say, I'm going to move these two around and swap them. Here to here, and here to here, okay? I'm just moving them around. You might even say, instead of swapping them, you could say that I'm just taking this one and bringing it over here. Since this is always a 1 in front of here, now this is y equals negative 1x plus, this is a positive over here, 3, the cube root of 8. Remember, the cube root of 8 we said could be 2. So now we're just rewriting it to say y equals negative 1x plus 2. And that's exactly what they have over here. So this does represent a linear function. 18 is for you to do. 19 is for me. It says 2 plus y equals x plus 4. All right. To work this problem, we see that we're going to have to, we want y over here, we need to bring the number over here. So we're going to minus 2 from both sides. This gives me y, and they are like terms, so I can't combine them, equals x plus 4 minus 2 is 2. So that tells you right there, it can be written in the form of y equals mx plus 2. This is a linear function. Okay? That says you can rewrite the equation as y equals x plus 2 by subtracting 2 from both sides. Because this is in the form of y equals mx plus b, the equation does represent a linear function. Number 20 is for you to do. 21. Now it's saying x minus y equals the absolute value of negative 54. Okay? There can be some shifting around here. I could bring the y to the side, making it positive. I could leave the x over here. And then I could bring this over here. because the absolute value of negative 54 is 54, the equation y minus x equals the absolute value of negative 54 becomes y equals, or x minus y equals 54. You can rewrite the equation x minus y equals 54 as y equals x minus 54 by subtracting x from both sides, then dividing both sides by negative 1. Because this is in the form of y equals mx plus b, the equation represents a linear function. And this is exactly what they did here. They added y to both sides. Now this is x equals, well, this is going to be the absolute value of negative 54 plus y. And then they realized that the absolute value of 54, negative 54, is 54, right? So this is plus y equals x. So what they did here is subtracted 54 from both sides. This is going to give us x minus 54 equals y. And if we can write this, I can swap these sides, making it y is equal to x minus 54. Okay, and now you can see where they got y equals, I'm trying to find my dot here. Sorry, there it is. Y equals x minus 54. All right, so this is a function, a linear function. All right, you got number 22 to do. I'm going to go ahead and work on the next one, 23. Which of the following equations does not represent a linear function? Which one is not a linear function? Select all that apply. Okay, so this square right here would take this and not be a linear function. Even if I put y on one side and brought the x over here, it would still be squared. A is not a linear function. When it comes to D, well, this is the same as saying y is equal to negative x plus 0, okay? So this is a linear function. Then we have B. We can go ahead and combine the like terms here. And if we do, we're going to subtract 3 from both sides. We're also going to add x to both sides. And if we do this, y will remain over here. And we're adding x over here. So this will equal the x, and then 0 minus 3 is negative 3. This is 1. This is a linear function. Then we have over here y equals 1/2, and then x over here is a power. We don't know what that power is, plus 9. This is not a linear function, so we cannot have an exponent up here. This says x equals 8. All right, if x equals 8, that means on a number line, okay, wherever the number 8 is, right, that means it's constantly going to be 8 all the time, right? That is not a function. It doesn't pass the vertical line test. And then we have f. It's the square root. This is not going to be a function. The only ones I think are functions are d and b. I could be wrong. Let's find out. So a, c, e, and f. A, c, e, and f these are the ones that are not representing a linear function. You cannot rewrite these, as I stated over here. So the only ones that are linear functions are going to be d and b. Okay, b and d, just like I said. All right, let's go ahead and let's see. You cannot rewrite the equations. 12 equals negative x plus y. You cannot rewrite x is equal to 8. You cannot rewrite y is equal to 1/2 with the power of x plus 9. You cannot rewrite y equals the square root of x plus 3 in the form of y equals mx plus b. So they do not represent. However, you can rewrite the two that I showed you here, one to be y equals x minus 3, and the other one to be y equals negative x, right? All right, so let's move on. Number 25 is from me to do. Graph the linear function represented by the table. If I was to graph this, I'm going to plot the points, then these would be my x coordinates, these would be my y coordinates each time. So over here I would have -2, right, and then 7. I'd have -1 and 4. I would have 0 and 1. I'd have 1 and -2, and I would have 2 and -5. All right, numbers 26 is for you to do. Number 27, graph the linear function represented by the table. Again, I'm going to go ahead and graph all these coordinates as xy coordinates, and if I do, I have -5 and 15, so I'll go to -5. This is -8, then -5 would be about right here. And then -15 would be about right here. Then I have -3 and -11. -3 would be about right here, and -11 would be here. I also would have 3 and 1, so this would be 3 and then 1 here. I'd have 5 and 5. This would be about 5, right? Because if this is 8, this must be 4, so a little bit more would be 5. And then again, a little bit more than 4 would be 5. And then I have 8 and 11. So 8, I would come all the way up to 11. All right? Number 29 is for me to do. Find the domain of the function represented by the graph. Determine whether the domain is discrete or continuous. Discrete or continuous. Okay, so because this has dots, it's discrete, right? Remember, it just has coordinates here. It doesn't have a line saying that everything encompassing it. So number 29 is going to be discrete. The domains 2, 4, and 6. It is discrete because the graph consists of individual points. Number 30 is for you to do. 33, the linear function m equals 10 minus 1.44p represents the amount of money in dollars of money that you have after printing p photographs. Okay? So interpret the term and the coefficients. Well, if we do this, the constant term is 10. Okay? That's what we're starting with. It represents the amount of money you have before printing any photographs. Then we're subtracting $1.44 per photograph, right? So let's see, you have before printing any photographs, and the term negative 1.44p represents the cost of printing a photograph. So the coefficient negative 1.44 represents the cost of printing one photograph. B says find the domain of the function. The domain. Is the domain discrete or continuous? Well, it's not going to let you print part of a photograph. So you cannot print part of a photograph, only a certain number of photographs. Because P represents the number of photographs, it must be a whole number. Also, if D equals 7, well, then M equals 10 minus 1.44 times 7, which would be a negative 0.08. And you cannot have a negative amount of money. So the maximum number of photographs you can print is 6. And the minimum is 0. Since you cannot print a negative number of photographs, so the domains are 0, 1, 2, 3, 4, 5, and 6. And it is discrete. All right. Number 6 says, or C says, graph the function using the domain. If I take these coordinates here, when I bought 0 photographs, right, I still have $10 in my pocket. When I have 1 photograph, I have $8.56 left. So that's 1 and 8.56. So we're starting at $10. That's what we started with. When we buy one photograph, we've lost $1.44. We buy two photographs, we've lost another $1.44. And now that's two photographs, and that leaves us $7.12, 7.12. And as you can see, every time I buy a photograph, my amount goes down by 1.44, up until the point where it can't go down anymore. All right, 6 is the maximum number of photos I can buy. All right, looks like we're going to be gearing up for 3.4. So that was the last one for me to do. Have a great night, and I'll see you in class for grading.